Hello, so I am doing free response number 1 from the 2019 AP BC Calc exam. So the question asks, or states, fish enter a lake at a rate modeled by the function e given by e of t equals 20 plus 15 sine of pi t over 6. Fish leave the lake at a rate modeled by the function L given by L of t equals 4 plus 2 to the 0.1 t squared. Both E of t and L of t are measured in fish per hour, and t is measured in hours since midnight. So part A says, how many fish enter the lake over the 5-hour period from midnight to 5 a.m.? Give your answer to the nearest whole number. So for this, we're going to be writing an integral. So our integral will be from 0 to 5, and so it's asking how many fish enter the lake, so that would be given by e of t because that's the rate that fish enter. So we'll do the integral from 0 to 5 of e of t dt, and then we can plug this into the calculator, and we get approximately 153 fish. Okay, part B. Part B asks, what is the average number of fish that leave the lake per hour over the 5-hour period from midnight to 5 a.m.? So we're also going to write an integral for this, but it's asking us for the average number of fish per hour. So we start with our normal integral for how many fish leave. We have the integral from 0 to 5 of L of t dt, but since this is the average, we are going to divide that by 5 for 5 hours. And we get 6.059 fish per hour. Okay. For part C, at what time t for 0 is less than or equal to t, which is less than or equal to 8, is the greatest number of fish in the lake? Justify your answer. So we know that there's going to be a max or min when the derivative equals 0, so we just need to know what the derivative of. So the derivative is going to be the total number of fish entering minus the total of fish leaving. So we get e prime of t minus L prime of t equals 0. Or we can rewrite that as e prime of t equals L prime of t. Okay, so now we can plug the equations into our calculator. We can find the derivative of these using our calculator, and we can plug them in to find what t is. And we get that t equals 2.833. Okay, now we need to justify why this is a max. So, in looking at the graph, you can tell that it goes from positive to negative. So what we can say is e prime of t minus L prime of t goes from positive to negative at t equals 2.833. So the number of fish goes from increasing to decreasing, meaning there is a max. And so that's the justification that we need. Okay. Now looking at part D, we see that it says, is the rate of change in the number of fish in the lake increasing or decreasing at 5 a.m.? Explain your reasoning. So to find this out, we know what the rate of change is. That's it'll be e of t minus L of t, but it's asking is it increasing or decreasing. So we're going to look at e prime of t minus L prime of t. And then we're going to evaluate e prime of t and L prime of t at t equals 5. And then we'll solve, and if we get a positive, that means it'll be increasing, and if it's negative, it'll be decreasing. And we get that it equals negative 10.723, which is less than 0, meaning that thus the rate of change is decreasing. And that is all for problem 1. That's everything for problem 1. Awesome.